Hey friends, good morning to everyone, and today I'm going to discuss about the very important topic from physical chemistry, that is the Maxwell relationship. Now there are 8 relationships which are called Maxwell relationships, and actually the 4 are called Maxwell relationships and other 4 are derived from these. So these 8 relationships are very important because each year in CSIR exam or GATE exam they ask you question related to this. Either they can ask some mathematics like numerical problem or some other relation which you have to derive from this Maxwell relationship, or they can even directly ask you the relationship. So to do this well, it is very so you have to do this well, okay, because if you remember this 8 relationship, you can easily get 4 marks. Now remembering 8 relationships in a normal way is very difficult. You can forget it anytime, but today I will show you a trick how you can remember these 4 relationships, actually these 8 relationships. Okay, so let's start. So for that you have to first write down 4 thermodynamic properties. This is entropy, then pressure, then T means temperature, and V means volume. So these 4 properties you have to write down in the 4 corners of this box. Now you can write remember this order by this term sportive. Okay, this SPTV, this sportive word, if you remember, you can easily understand, easily recall the order SPTV. Now this was taught by one of my very good physical chemistry teacher in my BSc days. Okay, so now what you have to do, you have to put the other thermodynamic properties, like here you have to put U, SUV, and here is HP, and here VAT, and here PGT. So this thing you have to just remember that how you have to put these all things. And now draw one arrow here and one arrow here. So you have to remember the direction of these arrows from S to T and V to G, that is from top right to bottom left, and from the from the top left to bottom right. Okay, these arrows you have to remember, and this thermodynamic properties where you have to put this here. Now if you remember this thing, you can easily derive 8 relationships from this strategy. Okay, now let us first take a partial derivative. Let's say ds dv. So we are taking ds dv. So if we take ds dv, the corresponding parameter, that is v, if we go from here to here, and then we have to fix the constant term, this one. So if we come in this direction, we have to fix this term. So here the constant term will be t. It will be equal to, so so first we are taking ds dt, then the right hand side we should have dp dt. So we will have dp dt, and in this case the constant will be v. Okay, now you have to determine what will be the sign of these two derivatives. Now you can see in both cases the arrow is from S to T, and we are also coming from S to V. Okay, so we are coming from this direction, and arrow is also from top to bottom. So this is why here it will be positive, and same case for this one, that is we are coming from top to bottom, and the arrow is also from top to bottom, so it will also be positive. So this is number 1 relationship. Then the second relationship. So now we can do the reverse, that is dv ds. So if we take dv ds, so then we have to, so now we are going from bottom to top, so we have to fix the constant p. So here you will have p, it will be equal to same dt dp at constant s. Okay, now you can see in both cases we are going from bottom to top, but arrows are from top to bottom. That so in both so in front of both of the derivative there will be negative sign, but they will cancel out each other, so you will again get the positive relationship. Now the second third relationship. So now you can have dpds, that is we are coming from this direction, this to this. Okay, now we have to fix the constant as v, and here we will have dt dv at constant s. Okay, so first dp ds at constant v and dt dv at constant s. Now you have to determine the sign. So you can see when we are coming from dp ds, we are coming from this direction to this direction. The arrow is also from right to left, so here you will have positive, but in this case you can see we are coming from right to left, dt dv, but arrow is from left to right, so s to t, so here it will have negative. Okay, now the fourth relationship, just we have to do the reverse, that is ds dp at constant t is equal to dv dt at constant p. Okay, now you can see again first relationship ds dp. So ds dp, we are coming from left to right, and arrow is also from left to right, so it will be positive. But in this case dt dv, okay, we are we are doing dv dt. So dv dt, we are going from left to right, but arrow is from right to left. Okay, so in this case here you will have negative. So these are the four relationships. These are called Maxwell relationship, and it's very important. You have to remember it, but you don't have to remember this four relationship. If you just remember this a particular strategy, you can derive anytime these four relationships. Okay. So now let us determine the another four relationships which are not actually Maxwell relationship, but they are also very important. So first we write for dg. So this relationship we all know that dg is equal to vdp minus tds, sdt, vdp minus sdt. Okay, so in this case how you will remember the relationship. So look, you are getting v dp, that means you are multiplying v with dp, but don't think this as v dp, consider it as dp into v. If you consider the multiplication as dp into v, although the right way of writing is this, but for the sake of simplicity, you can take it v into dp into v minus dt into s. Always write in this form, but when you are deriving the equation from this particular table, then you write like this. So now you can see you are multiplying dp with v, and the arrow is from p to v, that's why here you have positive. But when you are multiplying dt with s, in this case the arrow is in the reverse side, that is from s to t, not from t to s, that's why here you have negative sign. So let's do the thing for dA. Let's say we want to determine dA. So what will be the formula for dA? Now you can see in this case we should multiply it with, so dt into, so actually dt into s. Okay, and the other thing will be dv into p. So dv into p. Now you can see it is from we are multiplying dt with s, but the arrow is from s to t, that's why here you will have negative sign. And also here you are multiplying dv with p, but arrow is from p to v, so here again you will have negative sign. So let us do it for du. So in case of du, you will have dv into p and ds into, so dv into p and ds into t. Okay, so tds. Now you can see you are multiplying dv with p, but the arrow is from p to dv, so here you will have negative. But in this case you are multiplying ds with t and arrow is also from s to t, so that's why here you will have positive. And the last thing, dh, so it will be df into t and dp into v. So now again you can see you are multiplying ds with t and arrow is also from s to t, so here you will have positive. But in this case you can see you are multiplying dp with v and also the arrow is from p to v, so that's why here you will have also positive. So these four relationships you can also determine. You have to just remember that the multiplication is always from in cross, that is one corner to another corner, and that is which parameter you want to determine. You have to take the delta form or d form of the parameter which is adjacent to it. So when you are determining a, you have to take dv and dt. So you can see we are taking a, so we are taking dt and dv. You can't take ds and dp for a. Okay, so this thing you have to remember, then you can derive these four formulas easily. Now when you know these 8 formulas, you can easily derive many other formulas from this single from this particular 8 formulas. So this is very important. I hope I am able to explain how you have to do it, and I will put the jpeg format of this particular formula sheet on the on my Facebook page. You can get it from there. So thank you for watching and best of luck.